Ready-made maths YouTube training videos. Teacher and teaching assistant training for mental mathematics in Key Stage 2. Today we're going to be looking at our first arithmetic, number bonds.
Good morning and welcome to the first Ready-made Maths YouTube video, Mental Maths for Key Stage 2. What we're going to be looking at today is the first strategy of 5 that I'm going to be taking you through this week, looking at how to really help support children in Key Stage 2 develop mental mathematics strategies. Today's strategy is number bonds. Over the course of this session, what we're going to be doing is looking at how to start with 2-digit numbers, a long string of them, and use number bonds to develop mental arithmetic strategies. We're going to progress on to 3-digit, 4-digit, and we're even going to look at how number bonds can be used to support the teaching and understanding of decimals. What we're also going to be doing is using some practical apparatus to support the understanding of mental mathematics, so that when we are teaching children, it's not just a case of doing it in your head, but we're also going to show them a visual that will back up that understanding at the same time. The video that you're looking at today also complements the Key Stage 1 video, so you may wish to look at that one first. The Key Stage 1 video starts off with simple individual single-digit numbers and builds up towards 2-digit numbers. So if you do want to have a quick refresher, do have a look at that video before moving on to this one. So let's kick off with something that on the surface looks like quite a complex calculation. 28 add 77, add 66, add 42, add 94, add 53. And imagine the majority of children in year 3 or year 4, possibly even in year 5, 6, would look at that and probably put all of those numbers into a column and try to add together that way. What we're going to look at is how we can use, first of all, apparatus to demonstrate it, and secondly, how we can then use that as a jotting on the whiteboard. So if you look at the base 10 and how that's been arranged on the table, what you should see is, first of all, in the tens, you can see that the 70 is a 50 and a 20, and the 7 is a 5 and a 2. If we look at the 66, you'll see in the tens, 50 and 10, and in the ones, 5 and 1. Arranging the apparatus that way is far more efficient. Imagine with the number 77, that I'd set it out like that, you wouldn't actually know what the number was. You'd have to count each individual piece, whether it was the tens or the ones. But by arranging it in a tens frame style, like so, straight away, it makes it much easier to see the numbers. And again, it doesn't even matter which way around we do it. If you look at the 77, the 7 is a 5 and a 2 with the 5 first. If you look at the 28, you can see the 5 there and the 3 on the other side. It really doesn't matter as long as you can see the 5 and a bit. Now, looking at the apparatus now, how can we use the idea of number bonds in order to make this calculation much more straightforward? Well, what I'm going to do for the time being is ignore the tens and just look at the ones. I can look at the 28, 2 tens and 8 ones. How many more do I need to make a new 10? I've got 8, I need 2. Luckily, I happen to have a 2 over here with the 42. I can put those together and exchange them for another 10. Continuing to the 77. I can see 7 tens and 7 ones. How many more ones do I need to make a new 10? Well, I need 3, which I can take from over here, put those together. I can now see I've got another 10, which I can exchange. Finally, I think you can see straight away, we've got 66 and 94. Now again, there's different ways I could do this. I'm actually going to move the 6 over here this time. I'm going to put the 6 with the 4 over here. Again, that's going to give me another 10. And hopefully, this should make the calculation considerably easier. What I'm now going to do is, you can see I've circled the ones that I put together. I put the 77 with the 53, I put the 28 with the 42, and the 66 with the 94. So I'm going to put the tens together that I've created from those numbers. So if I start off with the 28, I'm going to put that 28 with the 42. And what we ended up with, once we combine the tens, is 70. What I'm now going to do is put the 77 with the 53, as I move those 5 tens over there, and then these 3 tens over here. Hopefully we can see we've now got 10 tens, and those 10 tens can be exchanged for 100. The final pair of numbers that we put together was 66 and 94. Now straight away I can just move that 10 over here. I can put the 60 down here, and again we've got 10 tens here, which will make another 100. So the numbers that we've ended up with, after we've added them together, we've ended up with 70, we've ended up with 160, and we've ended up with 130. Now all we need to do is to calculate what we've got left. Well, we've got 130, we've also got 70. I'm going to put the 30 from the 130 over there. I'm going to make another 100, and that gives us a final total of 360. So moving over to the board and looking at what that calculation looks like just when you look at the numerals, we can see the same number bonds but set out obviously just in a simple horizontal calculation. What we'll do is the same strategy that we did on the table with the resources. We're looking for that number bond in the ones to make it easier to calculate. The first thing I spot is 28. The 28 is going to go with the 42. So if I was to put the 28 together with the 42 and join those two numbers together, there's three different ways we could calculate. We could do the 40 and the 20 is 60 and the 8 and the 2 is 10. Put them together, that gives us 70. Alternatively, we could put the 2 with the 28 to make 30. 30 and 40 gives us 70. Thirdly, we could put the 8 with the 42, which will give us 20, and 50 equals 70. Every time you meet a number bond, you've always got those three options with the numbers and the ones. Separate partitioning or pass the ones over from one side to the other. We're going to extend that strategy later in the week in an activity called Manipulate the Calculation. The next one we're going to look at is 77. And again, 7 ones and 3 ones. 7 and 3 always go together, so we're going to basically put together the 77 with the 53. And let's see the three different ways that could be done. 70 and 50 is 120. 7 and 3 is 10. Put those together to make 130. Alternatively, we'll put the 3 over here. 77 and 3 is 80. 80 add 50 is 130. Or the final option, we put the 7 over there and we end up with 70 add 60. That's probably the easiest one because we can double and adjust with that one. Double 60 is 120 and 10 is 130. The final two numbers probably, although there are three options, is definitely an easier way out of those three. I would definitely on this version put the 6 with the 94. 94 and 6 is 100 and we add the 60 to get us to 160. What we then did, if you remember back to the strategy before, we took the 70 and again we can see a number bond straight away. 7 and 3 is 10, 7 tens and 3 tens equals 10 tens. So 70 and 30 is 100. 70 and 130 gives us a total of 200. We add the 200 to the 160 and we get a final total of 360. So what we've done is we've managed to move away from having to use a long-winded vertical column method. We've been able to pair them together really quickly, use a few jottings to show it, and eventually the more children work on simple things like that, they'll be able to start using those methods all of the time and eventually just do them in their head. Now, on the surface, this one looks very, very complicated. I've taken some of the numbers from the ready-made maths number wall and actually created a 3x3 grid. The simple challenge is, I want you to have a go at this in a minute. You're going to pause the video and have a go at trying to pair those numbers together, and obviously there will be one left at the end, into number bonds so that you can find the total of the entire grid relatively quickly. So what I want you to do now is like to pause the video, get some pencil and paper out and decide which numbers are going to go together. Let's have a look at which pairs we put together. Probably better off to start with the 108. What I'm going to do is I'm going to bring the 108 down to the bottom and I'm going to put the 108 as a number bond with 42 because 8 and 2 is 10, so we can put the 108 with the 42. Looking now at the top of the board, we've got the 45. I'm going to put that 45 with the 55. That should give us another number bond. We'll have a look at the total in a minute. We've got the 144 here. I'm going to shift the 144 along. And again, using that idea of number bonds, well, 4 and 6 is 10. I'm going to put the 66 with the 144. I've also spotted 60 and 40 is 100 there as well, so we can use that one with two different number bonds. I've got 63. Now the 63 is going to go with the 17 because there's 3 and the 7. And that, leaving us with the 10 at the end, should enable us, let's put the 10 over there for a minute, should enable us to work out the total relatively quickly. Let's have a look. Well, 55, we're going to pass that 5 over here, and so I end up with double 50. That gives me 100. Again, this one's very, very straightforward. We've got 100, another 100 because of the number bonds, and the 10. So that gives us 210. 63 and 10 is 73, and 7 is 80. And finally, the 108 with the 42, I'm going to bring the 8 over there to make that into a 50, and that gives us 150. We've also got over here the 10. What I'm going to do with the 10 is I'm going to add it to the 80. So 80 add 10 equals 90. What we can then hopefully see is our final number bond. We've got the 100, which is absolutely fine. We've got the 210, and if I take the 210 and put that with the 90, the 210 and the 90 gives me 300. That leaves us with basically 300, 400, 550. So basically, using that strategy of number bonds, we've turned 9 different numbers, we've added them together with a very, very straightforward mental arithmetic jotting. What we can also do when using number bonds is look at the 10s as well as the 1s. So although we could definitely see some 1s here, the 9 and the 1 would go together, potentially, and the 7 and the 3 will go together there. What we can also do is put the numbers together using the 10s. Have a look at the numbers on there, just pause the video just for a second and see if you can see which ones will go together. So starting with the 49, we'll bring the 49 down to the bottom. 49's got 4 10s, and again, using the number bond, we can see that 66 has got 6 10s. So we can straight away see we've got a number pair there to 100. If I put the 71 next, and I put the 71 with the 33, we've got 7 10s and 3 10s. Again, 10 10s, another 100. We could then maybe move to the 27, put the 27 on. 27's got 2 10s, 89's got 8 10s. Again, put those together, another 10 10s or 100. And finally, we put the 96 with the 17. So just by pairing all those up, we've automatically made this calculation so much easier. 100, and then 6 add 7 is 13. 100, 7 and 9 is 16. 100, 3 and 1 is 4. And 100, 9 and 6 is 15. If we now want to find the total of those, we've got another number bond. We've got 116 going together with 104. Put those together, we get 220. What we've got left then, 113 and 115, 228. Oops, 228. Add those together, and our final total is 448. So again, what we've managed to prove using number bonds is we can have a whole load of numbers and basically make the calculation much, much more straightforward by finding a really simple way of pairing the numbers together. Moving on to 3-digit numbers, what we can now do is we can look at number bonds in the 1s, we can look at number bonds in the 10s, and potentially we can even look for number bonds in the 100s. If we've got to add those 4 numbers together, again, take a second, pause the video, have a quick look and decide what number bonds are you going to use. So hopefully you put the 457 with the 343 and the 265 with the 125. From that point there are various ways we could work it out. We can just do the straightforward partitioning. 790 and 10 gives us 800 on that side, and 380 and again 10 gives us 390, and we add those together to get 1190. That's one way we could do it. A second option will be to leave the hundreds as they are and just add the 10s and 1s. 57 and 43 gives us 100, 65 and 25 gives us 90, and if we then just add the hundreds up, 400, 600, 900, 1000, which gives us again 1190. So another really easy way of using number bonds. Another really interesting option is to keep 457 as a whole number and just add the 3. That gives us 460, and what's left from there is 340. Doing the same with these, pass the 5 over to the 265, we get 270 and 120. From that point, again, we get 800 and 390, which again gives us 1190. The point about using numbers in this way is that whenever you see a set of numbers, there's generally always a number bond somewhere that you can use. What we're going to do now is we're going to go over to the desk, just play a little game. This is a game that you can set up at home, or even better, if you've got a group of children, let's say in year 4, who are working on number bonds, set this activity up for them and let them have a go. So the activity we're about to do now, I've used some mini whiteboards, but again, this could just be done with pieces of paper. What I've done is I've taken 3 dice, a hundreds dice, a tens dice and a ones dice, and I've created lots of numbers which I've written on there. For example, that would be a 300, a 0 and a 2, so that will give us 302. I rolled those dice 9 times and wrote the 9 random numbers on the little mini whiteboards. So what we're going to do now, I'm going to ask my daughter Lydia, who's going to come and help me with this activity. She's going to choose a random 4 boards from the selection on the table. And what we're going to do is I'm going to pause the video and then you have a look at them, I'll have a look at them, and we'll see if we can spot any number bonds that we can use to find the total. Off you go, Lydia.
Okay.
Tell me the number as it comes up.
328.
328. Board number 1. Board number 2.
232.
Oh, 232. I think I can spot a number bond already. Let's have a look at this one.
914.
914.
And 136.
And 136. I think we're very lucky with those ones, actually. Have a look at those. Pause the video now and let's just see what totals we can come up with. Okay, now I asked Lydia to have a look at those and see if she could spot the number bonds. And what she's done there is she's basically put the 2 subtotals. The 900 went with the 1. The 900 went with the 100 to make the 1,000. The 30 and the 10 made 40, and another 10 makes 50. So the first pair was 1,050. We then have the 300 and 200, which is 500. 30 and 20 is 50, and another 10 is 60. That just leaves us with the final 2 numbers to add, 1,050 plus 560. Well, we've got 1,000, we've got 500, and then we've got a 50 and a 60, which is 110. That makes 1,610. Now things are getting quite complex. If you were to see 3 4-digit numbers, probably the first port of call will be to put them into a column method. And that probably will be the quickest way to get the answer. But if you want to develop mathematical fluency with children who need to work at a slightly higher level, maybe in year 4 or year 5, or again to develop your own fluency, what number bonds can we spot here that will enable us to get the answer to this calculation? So I'm going to look at it and just see what I can spot. Well, straight away the first thing I see is 4,000 and 6,000, so I can jot down 10,000 there. That's immediately got rid of 2 of the bigger numbers, and again we've got 100,000 that's left over there, which I'll just write down. We'll move on to the hundreds. What can I see in the hundreds? Well, I can see a 800 and a 200. So again, that's going to give me another 1,000. We'll do that one. And again, that just leaves us there with a 300. So I'll put that 300 down there. We'll now move on to the tens. Well, there's a 50 and a 50 there. So 50 and 50 gives me another 100. We've got a 30 here. We've actually got an 8 and a 2. That's another 10, so 30, 40 and 6 is 46. So let's add that together. 10,000, 11,000, 12,300, 446. So 12,446. I'll just circle the 2 to go with the 8 there as well. Let's have a look at it as a column method. Could we use the same strategy? Well, we could. 8 and 2 is 10. Rather than starting with the 8 and 6, we'll start with the 10 and then we'll add the 6 to make 16. We'll carry our 10. We've now got 5 and 5 is 10. 3 is 13 and 1 is 14. 14 tens, 140. So I'll put my 40 there and carry my 100. I can spot a number on here. 8 and 2 is 10. 13, 14. This time it's 14 hundredths, or 1,400. As we move to the final column, 6,000 and 4,000. That is 10,000, 11,000, 12,000, which again gives us 12,446. So whatever the size of the numbers, if you want to just develop your mathematical fluency, it's a really good idea to do something like that. Let's just see how we can make it easy by spotting number bonds. Even when dealing with decimals, we can use the number bond strategy to help make the calculation a little bit simpler. Having a look at the numbers here, what you'll notice is I've used Numicon rather than using it for tens and ones as we would normally do. As you're working with children, let's say in year 4, it makes real sense to use Numicon to represent the whole, or 10 tenths. So if we now look at this piece over here, this used to represent 7, it now represents 7 out of 10, or 7 tenths. What we can see now are the numbers 5.8, 5 wholes and 8 tenths, 3.7, 3 wholes and 7 tenths, 2.2, 2 wholes and 2 tenths, or 22 tenths for year 5 and 6, and 8.3, where we can see 8 wholes and 3 tenths, or 83 tenths. Various different ways that we can use those numbers. What we're going to do now is calculate them by using the number bond strategy. So straight away, hopefully you'll spot we have a 7, which is now 7 tenths, and a 3, which is 3/10. We put those two together, we now make another whole 10/10 or 1 whole. We can do exactly the same with the 8/10 and the 2/10, and again, we can make another whole. What I'm now going to do is I'm going to rearrange them. So I've got my 5 over here. That 3.7 now becomes 4. My 2.2 now becomes 3. And over here, we can see that we've got 8. What we can finally do is add the whole numbers that we have together. There aren't actually any number bonds we can use now, so I'll just basically start from this side. 5 and 4 is 9, 9 and 3 is 12. And now we've got a number bond, 12 and 8. It makes a grand total of 20. As before, with all of the other calculations, there are various ways that we can use those number bonds. The 5.8 and the 2.2, we could just put them together as a whole number. 5 and 2 is 7, 8/10 and 2/10 is a whole, that gives us 8. 8 and 3 is 11, and another 1, using the tenths, gives us 12. That's another option, which is probably a very straightforward way. That gives us our total of 20. Alternatively, what we could do is we could potentially put the 5.8 with the 0.2. 5.8 with the 0.2 gives me 6. I'll put that 2 down there as well. If I put the 3.7 with the 0.3, I'm going to put that whole number there with the 0.3. Draw a little line over there, and that will give us a 4 and the 8. And interestingly enough, we now end up with 2 pairs of number bonds. 6 and 4 is 10, 8 and 2 is 10, and again, that gives us a total of 20. Basically, as soon as you can spot a number bond, you can see whichever way we do it. That's why numbers are so powerful. There's lots and lots of different ways we can manipulate them. You always end up with the same answer. You just choose the one that you think is the most efficient, or the one that you think will work best for you. That's the end of the first mental arithmetic session for Key Stage 2. I hope you've seen how the whole thing develops with number bonds being used with 2-digit numbers to 3 to 4, and even with decimals. Might be worth practicing between now and tomorrow. Just have a little practice at home, just using dice or random numbers. Just generate your own 2-digit numbers, 3-digit numbers, 4-digit numbers, and even decimal numbers. And just look how easy it can be to add them together when you've got number bonds. Again, when you're back in school, if you're working with children at whatever level, from year 3 up to year 6, it's always worth having that strategy in mind, rather than always having to go for a column method. So I hope you've enjoyed that first session. I do look forward to seeing you all again tomorrow. What we're going to be doing tomorrow is looking at strategy 2. Thank you so much for joining me. I do look forward to seeing you again for the next video tomorrow.